4.3 Isomerism. Isomerism is defined as the existence of two or more compounds with the same molecular formula but different in structures. There are two types of isomerism. The first one is constitutional isomerism, or also known as structural isomerism. And the second type of isomerism is stereoisomerism. Constitutional isomerism or structural isomerism can be further divided into three types. The first one is chain isomerism. Second one is positional isomerism, and the third one is functional group isomerism. As for stereoisomerism, it has two types. The first one is diastereomer, and second one is enantiomer. This is an overview to the constitutional isomerism and stereoisomerism. We will discuss into details after this. Chain isomers are isomers that differ in carbon skeleton. Chain isomers can be either in straight chain or branch chain. Characteristics of chain isomers are they possess the same functional group, they belong to the same homologous series. They are similar in chemical properties but different in physical properties. This is an example of chain isomer. This is a brief guideline on how to draw chain isomers. First, draw the main chain. The main chain is the straight chain which contains all the carbon atoms. Example, if we have 6 carbon atoms. For the second structure, draw main chain but minus 1 carbon from 6 into 5. And add the balance group to as many positions as possible, but never add the balance group to the end of the chain. This is the example where we locate the balance group to the second carbon, or we put it to the third carbon. Next, draw the main chain but this time minus 2 carbons. From 6 becomes 4. And add the 2 carbon atoms, the balance 2 carbon atoms or 2 methyl groups to as many positions as possible. Example, to the second and the third carbon, or both located at the second carbon. Continue subtracting and adding groups in this fashion until you run out of carbons. The second type of constitutional isomerism is positional isomerism. Positional isomerism occurs in molecules which contain substituent groups or functional group of any type. Positional isomers have the same skeletal structures but differ in the position of the functional group or substituent groups. For an example, let's take C4H7. In the first structure, the functional group, which is carbon-carbon double bond, is located at the first carbon. In the second structure, the functional group is located at the second carbon. The molecular formula for both molecules remain the same. The type of functional group also remain the same, but the position of the functional group in the molecule changes. These are some of the examples of positional isomers. The first one, 1-chloropropane and 2-chloropropane. Second example, 1-butane and 2-butene. And the third example, 1,2-dimethylbenzene, 1,3-dimethylbenzene, and 1,4-dimethylbenzene. These are some of the examples of the positional isomerisms which are formed when we change the position of the subsequent group. The third type of constitutional isomerism is functional group isomerism. Functional group isomers have the same molecular formula but different functional group. The characteristics of functional group isomers are they belong to different homologous series. They have different chemical and physical properties. The example of functional group isomers is C3H8O. In the first structure, we have hydroxyl group as a functional group. In the second structure, we have alkoxy as the functional group. These are the pairs of compounds which exhibit functional group isomerism. The first one is cycloalkane and alkene. The second pair is aldehyde and ketone. The third pair is between alcohol and ether. And the last pair is carboxylic acid and ester. Let's try this example. A compound X has a molecular formula of C3H8O. Draw and name two possible structural formulae of X with different functional groups. It is 2-propanol and methoxyethane.